Hi guys, today's notes are on 9.8a and we're going to be using the sum and difference formulas today to evaluate different trig expressions that are not 45, 45, 90 or 30, 60, 90 triangles anymore. So first off, notice that the sum and difference formulas are up here, and I want you to be really careful as you're looking at these because there are some tiny differences. So if you have sine of a plus b, two angles added together, there's going to be a plus in the middle, but it's sine A times cosine B plus cosine A times sine B. You guys see how complicated or confusing it can get? If it's sine of A minus B, the sign in the middle is a minus. But take a look at cosine. Well, if it's a positive here, then it's a negative here, and everything switches to cosine times cosine and sine times sine. So there are these tiny little differences that you have to be really careful to keep in mind. And make sure that you catch all of the sign changes. The good news though is that the left side is exactly the opposite signs of the right side, so you should be able to only memorize one and then change all the signs for the right side. Okay. So in general though, one thing you need to understand is that sine of two angles added together is not equal to the sine of the first angle plus the sine of the second angle. And this is true for the other 6 trig functions as well. Okay, we used to only be able to find the exact trig values of multiples of 30, 45, and 60 using special right triangles, right? Like it'd be root 2 over 2. And now we can use sum and differences, these formulas, to find the exact trig values of more angle measures. So just a larger range of angle measures. We still can't do all of them yet, okay, but we can add in some numbers. So take a look here. We're going to use sum and difference formulas to find the exact value of sine of 15. Now, the first thing you need to know is that sine of 15 is... Oh, and I should say that we are going to be using these, right? So using these numbers, how do I add or subtract to get to 15? And so that is sine of 45 degrees minus 30 degrees. I could also technically do 60 minus 45, but I usually pick the smaller numbers, but it makes no difference, okay? So we are trying to use 30, 45, and 60, use these to add or subtract to given angle. Now, what we're going to do now is, since it's a subtraction problem, or it's a difference formula, we're going to go here and find it, and I'm going to write the whole thing in red just so that I keep track of this. Sine of A minus B equals sine A times cosine B minus cosine A times sine B. Okay. So before we can do anything, we probably need to draw a 45, 45, 90 triangle. So here, this is a 45, 45, 90, right? And then we need to draw a 30, 60, 90. So this is 30 degrees, which will be down here. Let's label these. So these are the values. And hopefully you guys remember that sine A is, sine is y. And this is x, right? So I'll write here sine, and this is cosine. And this is angle A, and this is angle B. So this is sine and cosine. Okay, so once I've labeled all of that, all I have to do is replace these 4 values with the corresponding sine and cosine. So do you see how here, according to this one, sine will have A be 45. Okay, so sine of 45 is root 2 over 2. Cosine of B, so I need to switch to this one and get the x value, is root 3 over 2. Minus cosine of A is the other value, which is 2 over 2. And then sine of B is 1/2. And so what we need to do now is to simplify as much as we can. Okay? So we have root 6 over 4, right? Multiply across. 2 times 3 is root 6, and 2 times 2 is 4, minus root 2 times 1 is root 2 over 4. Okay. What we're going to do now is just combine like terms, right? Combine. But we can't combine if they're not like terms. So we're going to just say root 6 minus root 2 all over 4. This one in your calculator, if you wanted to like punch this in now, you could say that it's approximately 0.2588. Okay? But your answer is this. Okay, so here's your U try. I'm going to ask you for cosine of 105. So the question is, using these three numbers, how can you get to 105? Okay. So hopefully you see that it's 60 degrees plus 45, right? And it doesn't matter if you use 60 first or 45 first, but I'm going to be consistent and always put my smaller number first. Okay, so I'm going to pause my video here. Actually, never mind. I'm going to write my formula first and then pause my video. So it's this one. Cosine of A plus B equals, maybe it would be helpful if I wrote, cosine of 45 plus 60 degrees equals to cosine of 45 times cosine of 60 minus sine 45 times sine 60. So I do need to draw the triangles for 45 and 60. I'm going to pause here and then show you guys after. Okay, here's my answer key. So notice that the numbers are exactly the same because we're still in quadrant 1. So everything just flips slightly. Make sure you don't combine radicals with different radicands underneath. Okay, so keep it, because this is a decimal and this is a decimal and they're not like terms. Okay, so now let's talk about tangent of pi over 12. 7 pi over 12. We know we're going to use the formula of, let's write it down, tangent A plus tangent B over 1 minus tangent A times tangent B. Okay, so we need to get to 7 pi over 12. And this is where it gets a little bit trickier. So when you guys are in radians, the radians for 30, 45, and 60, 30 is pi over 6. Oh, sorry, not over 60. Pi over 6 is 30, right? Pi over 4 is 45. And pi over 3 is 60. So how do I get to pi over 12? Well, I think I'm going to need common denominators with pi over 4 and pi over 3. So let's make this over 12. And over 12. To get 12, I need to multiply by 4, right? So 4 pi. And to get 12 here, I need to multiply by 3. So 3 pi. So what I'm going to do is take 45 plus 60, but we have to use radians because that's what I give you. And I know you're not going to be happy about that, but it is what it is. Tangent of, 3 pi over 12 plus 4 pi over 12. So if that's the case, then that's the same as saying tangent of pi over 4 plus pi over 3. Okay. And the reason I'm doing this is because when you think about it, you need to know what you're using. Okay. So let's just draw it out. We can now think in terms of degrees if we want to. So the first one is 45 degrees. Tangent is y over x. And we only need tangent. So for this one, this is pi over 4. Okay. for this one, we are going to just have 1. So let's write this out. Oops, sorry. So let's recap. Let's see. So here's the formula we're using because it's tangent. Anytime you see over 12, we're going to use the denominators that can have common denominators of 12. So it'll be 4 and 3. We're going to convert the 45 degrees as pi over 4 into 3 pi over 12. Sorry, and 60 is pi over 3, but we can change it by multiplying by 4 and 4. So sorry about that. So now we can just look here. I guess I should write it out, right? So I'm going to have tangent of A, which is pi over 4, plus tangent of B, which is pi over 3, all over 1 minus tangent of pi over 4 times tangent pi over 3. Okay. So tangent of pi over 4 we said was y over x, which is just 1. And then tangent of pi over 3, I do need to draw that one out. That's a 60-degree angle, which is root 3 over 2 over 1/2. So if you take root 3 over 2 over 1/2, you can cancel out the halves. So it's just plus root 3 all over 1 minus, and then I'm going to have, let's see, tangent, this times this, right? Because we're using the same values, tangent A, tangent A. The difference is we're adding on top and multiplying on the bottom. So we have 1 root 3. Now, hopefully you remember that we are not allowed to have radicals in the denominator, so you need to multiply by the conjugate. Oh, I wish I had a different color for this. I'm sorry. 1 plus root 3 and 1 plus root 3. Okay. Now, if I distribute, this is where you have to like sort of see it, right? So 1 times 1 is 1. Times 1 times root 3 is 1 root 3 plus 2, another root 3 is plus 2 root 3, and then root 3 times root 3 is 3. All over 1 minus, let's see, 1 times 1, 1 plus, and 1 minus, so these cancel, and then we'll have minus 3. And so when you have that, we can do 1 plus 3 is 4 plus 2 root 3 all over negative 2. Now you're going to divide here, here, let's do negative 2, and here, right, to cancel it out. So that gives us final answer of negative 2 minus 1 root 3. I know, that was so much fun. Okay, you guys are going to be pretty upset at me. Guys, this is going to be exactly the same except with a minus, right? So try it, but see if you can do it yourself. Okay, what is going on? I think that's the answer, but I wouldn't bet on it. I'm just like 90% certain. I'm sorry. You guys can tell me in class if I'm headed in the wrong direction. Okay, last one. We're going to do one example, and then you guys can try one of the 2 you tries. So right now we're going to be given cosine A and sine B, and then you have to find cosine of A minus B. Okay, so since we have cosine of A minus B, then I'm going to establish that the formula I need is cosine of A minus B, and I'm going to copy it from my trig values, or trig identity page. Okay, so the problem is that you don't actually know what degrees A and B are, right? So we have to figure it out. And so we know that from here, this is in quadrant 3, right? So if we drew it out, we know that cosine is opposite over hypotenuse. So we know that in quadrant 3, we have this. And here's my theta, so opposite, I should say A, sorry. So opposite is 4, and hypotenuse is 5. We know the sine is negative 4 because it's going down, right? Hypotenuse is always positive. Sine B is in quadrant 1, which is over here. So I'll call this B. And then sine is, oh dang it, sorry, -4 is my ka, so ka toa. But it's still -4 here. Okay, sine is so, which is opposite over hypotenuse, 5/13. Okay, these are both special right triangles. This is a 3, 4, 5. Okay, so you know that this is -3, -4, and 5. If you don't know that, you have to use Pythagorean theorem. Okay, but memorize the 3, 4, 5 triangle. The other one that I think you guys should try to memorize is a 5, 12, and 13. If you make that work, then this will always be 5, 12, and 13. Okay? So once I have that, then I can go through and fill in my numbers. You guys ready? Cosine of A is right here, is adjacent, well, I'm given that. Okay, so I have -4/5 times cosine of B is adjacent over hypotenuse, which is 12/13, plus sine of A, so is, oh dang it, is, let's see, -3/5, and sine is so, which is 5/13. Okay, and so at this point, all you have to do is multiply and simplify. So 48/65 minus 15/65, which is -63/65. Okay? And that is what cosine of A minus B is. Try that in your notes. I'll post the answer shortly, but see what you guys can do there.